students. So my name is Smaranika Sundar Rai of Electronics and Telecommunication branch, and this video is only prepared for first year students of Diploma Engineering. So today we are going to learn about rectifier. So rectifier converts AC to DC. So what is AC? AC means alternating current and DC means direct current. So AC waveform looks like this. So this signal has amplitude, phase, frequency. All three parameters are present in this waveform. And DC. DC signal looks like this. This waveform contains only amplitude. There is no phase and frequency. We have already discussed about PN junction. So, what is PN junction? It is the combination of P-type and N-type semiconductor. So, this PN junction is also known as diode. Means diode is a component that is used for rectification, or we can say diode is known as rectifier. So the symbol of a diode is like this, and this is the internal structure of diode. Diode has two terminals. One is anode, means positive terminal, and the other one is cathode, means negative terminal. So diode used for rectification, that means diode converts AC to DC. So rectifier classified into two types. One is half-wave rectifier and the other one is full-wave rectifier. Full-wave rectifier. Full-wave rectifier again divided into two types, that is center tap and bridge rectifier. First we discuss about half-wave rectifier. Half-wave rectifier consists of only one diode. So first we draw the circuit diagram of half-wave rectifier. The circuit consists of transformer, diode and load resistor. We generally get our output at load. So here we use a resistor as load. So we get our output here. So first we give input, that is a AC signal. This is the symbol of AC supply, and the AC signal is like this. This is one cycle. So we can say one cycle consists of one positive half cycle and negative half cycle. So first we give positive half cycle to the circuit. When we give positive half cycle, at that time this end becomes positive and this end becomes negative. And we the diode terminal means one is positive and other one is negative. So this side is positive and this side is negative. So in positive half cycle, diode D is forward bias. Forward bias. As we know, in forward bias condition, current flows through the diode. So in positive half cycle, current can pass through the diode D. So at the output, we get this type of waveform. Okay. Then after positive half cycle, next is the negative half cycle. When we apply negative half cycle, then end A becomes negative and end B becomes positive. Why? Positive half cycle and negative half cycle. Both are opposite in polarity. That's why when we apply the signal as per their polarity, here also polarity changes. Okay. So when polarity changes, at that time the diode D becomes reverse bias. So in positive half cycle, diode is forward bias, and in negative half cycle, diode is reverse bias. In reverse bias condition, no current flows through the diode. So at the output, we never get any signal. This process repeats again and again. So as per the process, at the output, in positive half cycle we get waveform. In negative half cycle there is no output. Again in positive half cycle we get output. Again in negative half cycle there is no output. So we can say in positive half cycle what happened? We get output, and in negative half cycle the input is suppressed. So here the rectification efficiency is very low and output gain is also very low. Why? Because it operates only in single half cycle. Okay, so this is all about half wave rectifier. Now we discuss about full wave rectifier. Full wave rectifier. As we know, full wave rectifier is divided into two types. One is center tap, other one is bridge rectifier. So first we discuss about center tap rectifier. Center tap rectifier. In half wave rectifier, we use only one diode. So we generally think that if we use one diode for one half cycle, then if a circuit consists of two diodes, then it is easily rectify both the half cycle. So in center tap rectifier we use two diodes. So the circuit looks like this. This one is the circuit. Here we use a center tap transformer. That's why this rectifier is known as center tap rectifier. So this circuit consists of two diodes and a load resistor and a transformer. So Here also we give input a AC signal. When positive half cycle is applied to the circuit, at that time end A is positive, end B becomes negative. At that time means in positive half cycle, diode D1 is forward bias and diode D2 is reverse biased. Why? Because when A is positive, diode D1, this terminal of diode D1 is positive, this one is negative. And here this terminal of diode D2 is positive and this one is negative. So plus plus, here minus plus. So plus plus is the forward bias condition. That's why D1 is forward bias and D2 is reverse bias. So in positive half cycle, current conducts only through diode D1 and this way, then through the load. As we know, diode is a unidirectional device and here the current pass only in one direction, that is from positive to negative. So current flows through this. There is no chance of conduction in this direction. Okay. So in positive half cycle, positive half cycle, current flows through upper half winding, then diode D1, then load R. As here we use a center tap transformer. This part is the upper half winding and this part is the lower half winding. Next, okay, next we give negative half cycle. When we give negative half cycle, at that time end A becomes negative and end B becomes positive, means polarity changes. So here minus plus and here it is plus plus. So in negative half cycle, diode D1 is reverse bias and diode D2 is forward bias, and the current flows through lower half winding, then diode D2 and load RL. So okay, negative half cycle, diode D2, load RL, then lower half winding. In both the cases, we can observe that through load, current flows in same direction. That's why we get waveform like this. Okay, in positive half cycle. Okay, next we discuss about bridge rectifier. So bridge rectifier. First we draw the diagram of bridge rectifier. So bridge rectifier consists of 4 diodes. The circuit diagram of bridge rectifier. Here we use 4 diodes, and here the circuit looks like a bridge formation. That's why it is known as bridge rectifier. So here also we give a AC signal as input. When we apply positive half cycle, end A becomes positive and B becomes negative. And when we give positive half cycle, means we can write in positive half cycle diode D1, load RL and D3. Through this path current conduct. So D1, RL and D3. So here we can write D1 and D3 are forward bias and D2 and D4 are reverse bias. Okay. Next we apply the negative half cycle. When we give negative half cycle, end A becomes negative and end B becomes positive. So in negative half cycle, current flows through D2, RL and D4. So we can write D2, D4 are forward bias and D3 and D1 are reverse bias. Okay. In positive half cycle, D1, D3 is forward bias, D2, D4 are reverse bias. In negative half cycle, D2, D4 is forward bias, D3, D1 is reverse bias. As per this, let's make the circuit diagram. Okay. So first we draw for positive half cycle. So for positive half cycle, the circuit looks like D1, D3, RL like this. Okay. So for positive half cycle, only these components are used for conduction. Then okay. Then next we draw circuit diagram for negative half cycle. Here the current will flow in this direction. Okay. 1 second. Okay. Let's compare the two circuits. Okay? See, this one is for negative half cycle and that one for positive half cycle. In both the cases, you can observe that current flows in same direction through the load. Only in that case we get a waveform like this. If the direction of current changes for every half cycle, then at the output we will get this type of waveform. So here we concluded that the AC converted to DC, but is this a pure DC signal? No, this is not a pure DC signal, because the pure DC signal looks like this. So this waveform is the combination of DC plus AC component. To get a pure DC signal, we have to use filter circuit after rectifier circuit. So in the next class, we will discuss about the filter circuit. Okay. So if we compare the full wave and half wave, then the efficiency of rectification is higher in full wave rectifier than half wave rectifier, and output gain is also higher.